All right, well, good morning. Welcome to week 11 of CNET58. And as I said in the chat, happy Star Wars Day, right? Today's May the 4th. So may the 4th be with you and all of us today. Today, we're going to take a look at PowerShell. So today's lecture in lab will be built around the concepts that are in PowerShell. Today's lab, if you have a Windows 10 machine, you can do it on your home computer. If you want to remote into your server, you can do it on that computer. If you want to remote into your server and open one of your virtuals, you can do it on one of those machines. So any Windows machine that has PowerShell will be capable of running the instructions, the code that I give you to run as we explore and investigate what is out there as far as PowerShell. All right. Now I wanted to also remind you, I'm going to send an announcement tomorrow or this evening at midnight, but the summer registration schedule opens up tomorrow. May 5th is the first day of summer registration. So if you have priority registration, I don't even know if they're still doing priority registration or how they're doing it, but check the portal for your registration date. And there's several course offerings for those of you that are in the CNET program or trying to get a certificate or a degree from CNET. There's actually going to be two sections of CNET60, which is the A+ prep class, and two sections of CNET62, which is the Network Plus prep class. There's a section of Tech 60, which is the technical services course and the customer relations course. And there's also a section of ELEC 11, which is the microcomputer applications class. So if you need any of those classes and you're available this summer, all of those will be offered online using Canvas. So you have an option to continue your studies through the summer session, which will then bring us into the fall. And I'll talk about the fall schedule a little bit later because it's still kind of in transition. As of right now, we're planning on offering courses both online and on campus or a hybrid of those two models. So we're talking about how we're going to do that. But for those of you that need CNET54, the troubleshooting class, which I know a handful of you do, that class will be offered as a hybrid. So the lecture will be online and then the labs will be in person. And the labs will be on campus in room 404. In 404, I believe that's on Tuesdays. And or Thursday. I don't remember the exact date because we're kind of moving stuff around to accommodate all the other classes. But that's in the fall. Okay, so I know like Louis and I think Alan and Al Michael are all waiting for CNET54 because we haven't offered it in a year. So anyway, if you have any questions about the schedule or about course sequence or anything like that, be sure to let me know. Just send me an email. For those of you that aren't aware, I am the department co-chair along with Professor Joe Denny, and this is my second year doing that. So I have a direct voice into scheduling and those kind of things. So we'll be good to go. All right. So this morning we're going to kind of step away a little bit from virtual environments and talk about PowerShell. And I've mentioned this throughout our other lectures where we had little PowerShell snippets, but PowerShell is the direction that an IT administrator, especially in a Windows environment, is going to have to be familiar with. And actually, I would even push that a little bit and say not just familiar, but almost an expert on PowerShell and writing commands and running these code snippets as scripts. So scripting within Windows, especially in a larger environment, is very, very important. All right. Before we do that, though, I did want to ask any of you, I know some of you ran into some challenges on last week's lab. I know, like Robert, you had a issue with the sysprep, and I know Luis, you had a couple challenges with some of the networking and with the router. And last week's lab there was a lot of moving parts, and if we were to say, you know, what would an employer expect a server technician to be aware of and be able to handle some of the challenges, you could look at last week's lab and say that's what a server administrator should be well aware of and be able to challenge or take advantage of the opportunity to set something like that up. So although it's difficult and you know, time consuming, that's IT. I mean, that's what it's like to be an IT professional, is sometimes you just have to, you know, figure out, why isn't this DHCP working? I mean, if you look at your server, everything is set up right? Your scope, your scope 1A and LAN A, LAN B is set up right, but why isn't that Win2, Win10-2 machine getting it? And the reason is because the router is not advertising DHCP on that other network. So, you know, you have to kind of think about it as far as what is going on, why is this happening, why is it getting an APIPA address when the other one gets a DHCP address, right? When 10.1 got a 192.168.1.100 something address automatically, but when 2 got a 169.254 dot something address, right? An automatic private IP address. Why is that? Well, you know, DHCP is working because when 10.1 got it and it's the same server. You could double check your settings. I mean, but chances are if you set up one right, you probably set the other one right. And the problem was that the routing and remote access does not, by default, send DHCP traffic, which is UDP, right? It's not going to forward that across its other network segment unless we explicitly tell it to do it. And that's when we went in and we set up that routing protocol that allows it to transmit the relay agent for DHCP. So it's those kind of scenarios that you run into on every project, on everything that you're working on. And one little simple, hey, I need to add another network segment, piece of cake, right? Add it in, put another network card in the router or connect another cable to the router. And all of a sudden that section doesn't get the access that you're expecting. You know, that's some real world troubleshooting. All right. Yeah. And as Louis said, the A+ and the Network Plus, all the summer and winter sessions courses, we use another company called testout.com, and they have some really good practice labs. And in fact, you can actually get an industry certificate from Testout. It's not as renowned as the CompTIA A+, but you get a cert if you pass the final exam in those courses as 70% or higher. You'll get a industry certification you can put on your resume as well. All right, so let me share any questions about last week's lab or comments. All right, I'll put it kind of in perspective. Last week's lab probably took you well over 3 hours. This week's lab will probably take you about half of that. So, you know, kind of give you a little breather after the hard work last week. All right, so I'm going to share my PowerPoint. Yeah, pinging before the disabling. That's good. I like that, Robert. All right, so let me make this. I'm going to move my speaker box up to the front. All right, so today we're going to take a look at some of the networking in Hyper-V, as well as, I don't know, probably up here is better, but also we'll look at PowerShell and some of the storage requirements. So let's get going here. So here are some of the objectives, and we'll discuss those as we go. So Hyper-V's virtualization of network allows us to create virtual networks that allow our virtual machines to connect to. Now, in our network, especially last week, we created 2 separate internal networks, LAN A and LAN B, right? And then we have an external network, which is the name of the adapter it's connected to, which is the Intel, whatever the adapter name is. That's an external network, okay? An internal network allows whatever's on that network to communicate. So if you've ever connected a computer to a switch, so imagine you have a computer on your bench and you have a switch on your bench, and you connect the cable from the computer to the switch, the network switch, and power everything on. Whatever is connected to that switch will be able to communicate with each other. So if we take another printer and connect it to that switch, and another computer, say a server with a file share or a DHCP server, whatever is connected to that switch will have layer 2, right? The data link layer connectivity with those devices. And then if we set up IP addresses and they're set up correctly, they'll have layer 3 address, right? They'll be able to communicate with an IP address. Okay. Now, the ability to build these virtual areas and network virtualization allows us to decouple or remove the network environment from the physical network infrastructure. And that is going to allow our virtual environments to kind of move away from the physical network into a virtual area where we can really isolate and set up services that are kind of tucked away underneath or behind our physical network, and really do some interesting experimenting and labbing and experiment, you know, to see how all of that's going to work together. So it's a very, very significant way of of learning about networking and getting some of this stuff to work. Okay, so the Hyper-V switch is all software based. So it's functions exactly like a physical switch. It does have a limitation to the number of connections. So just like if you go out and you buy a 16 port 802.3 AC router with a switch port on it, and you only have 16 connections, right? Whereas Hyper-V, it's maxed out at 256 connections. So that's a convenient number, right? That's a Class C typical subnet mask of 255.255.255.0 will give you 256 total IP addresses. Okay. Now, the switch also includes the ability to manage and set it up just like you would any other switch. So there are some policies we can enforce for security reasons, to isolate, and for service levels. So we're gonna walk through what that means. Okay. So to really understand the networking in Hyper-V, it's essential that we discuss the virtual switch, because that's what we're connecting to, right? And it's easy, I know, in some of these labs, just to follow the directions, right? Well, it says connect this machine to this network connection. So you just go into, first you create it in the virtual switch manager, new LAN A, internal, done. So I don't know what I did, but I did it. And then go into the virtual machine settings, change the network from, Intel, I'm going to drop it down and select LAN A. And then on the router, I'm going to add another switch, another network card, and it's going to be on LAN A and LAN B. And not really understand what has happened there. So we're gonna kind of explain that a little bit today. Okay. Now, in Hyper-V, the virtual switch or virtual network has really evolved over time. So it went from a basic network device to a more advanced, common in today's network environment with physical switches to mimic and be similar to that. Okay. Now, the virtual switch has three possible settings: external, internal, and private. Now, it can connect to either a single interface or network card of the server, or to multiple interfaces with what Windows calls NIC teaming. So you build a team, and this is in Cisco language, they refer to that as gosh, the term's escaping, but they use a different term. Other areas call it like bundling or bonding, network connectivity, but Windows calls it teaming. And if you have two network cards on your machine, you can go into the settings and set them up for a team. Okay. So here's a graphic that shows our virtual machine is connected to our host machine, right? All this is virtualized. And inside of our virtual switch, we have the internal network card that we assign via the settings, right? We go in, and when we build a VM, so when we say create a new virtual machine, it automatically starts with one network card. So we'll have a network card, and then in the settings of the setup, it will ask you, where do you want it connected? Either not connected, or you can hit your drop down and select one of your connections. Okay, once you select that, this stack with the port, which is like the physical cable connecting to the switch and to the network card, and then it's going to have this ingress and egress, which is the inbound and the outbound traffic. Okay, so it's going to have the protocol stake, the capturing extension, the filtering extension, the forwarding extension, the mini port edge, and then the port, and then it goes through all of the virtual switching to get to the external network card, and then go out to the whatever network this is attached to, especially if this is an external switch. If it's an internal switch, it sees the server, but it doesn't go beyond the server. External will actually go out and say we had a line here to the internet, it would have access to the internet via the VM. Okay, so the ability to understand this is important for us. Okay, now the Hyper-V virtual switch is a virtual layer of network subsystems that really is a layer 2 switch. Now, many of you have probably worked in on a corporate network, and they have now, it's very common to have layer 3 switches, which means that the switch can do both layer 2 and layer 3 addressing. So our layer 3 switches can do what's known as inter VLAN or inter network routing. Okay, they can't do internet routing by default. I mean, they can do internet routing, but it has to connect to an actual router. But they can do inter VLAN routing. All right, so that means that, like last week where we had LAN A and LAN B, those are two separate networks, right? And I asked you that question, why can't they ping, right? Why did that not work? And when they were on static, it worked because the router interconnects those two networks, because the router was on both of those same networks, right? The LAN A connection on the router was assigned 192.168.1.1 with the 255.255.255.0 subnet mask. And then Win10.1 was on 192.168.1.99 with the 255.255.255.0 subnet mask. So those two IP addresses are on the same network. They can communicate. And then on the other side, LAN-B's connection to the router was at 192.168.2.1 with a 255.255.255.0 subnet mask. And Win10.2 was on 192.168.2.99 with a /24 or a 255.255.255.0 subnet mask. So those two endpoints, routers 2.1 and 10-2's 2.99, they're on the same network and they're interconnected with the router that will allow that traffic. So the routing part of the router worked fine. The part that didn't work was when we put it to DHCP. Now with DHCP, Win10-1 was still on the 1.0 network with an address. Most of the time it got the 1.101. And the switch or the router was still 1.1. So those are still on the same network. But the LAN B, the router's network card did not change, right? It was still 2.1. But Win10.2 did not get a DHCP. So it went with an EPIPA, which is now a 169.254, which is not the same network of 2.1. So now there's nothing to route because the client is not on the same network as the router, so the router can't route anything. So that's what happened there. Now, if the router is a layer 3 address, okay, where switches are layer 2. So the virtual switch is part of the parent partition architecture and provides the network connectivity between the child partition and the physical network. And it's this switch that manages the data transmission, implements security for the virtual network between the virtual machines. Okay. Now, in Server 2012, Microsoft has made a distinct move to make their premise server infrastructure or their architecture cloud ready, right? So there are things when we do an install in the server manager, which is what we've used to install everything. A lot of times, if you look at the settings, there is a checkbox that says to attach this machine to a Azure domain, which is a cloud infrastructure. So the concepts, the way the servers work are identical. So the fact that we're doing everything locally, right? All of our servers are physically located in the stock room in room 406 in building 28B on Mount Sax campus. But the fundamentals that we're learning are identical to the ones we will need if those machines were in the cloud, okay? But just for conception and simplicity of deployment, we're doing them local. But what's really kind of interesting is the way we're accessing them is exactly how we would access if they were in the cloud, right? We would use some sort of remote desktop broker, which we're using Apache, but we may use, Azure services to do that. And then away we go with it. So Server 2012 is where Microsoft kind of shifted and said, we're going to really move away from premise technologies to the cloud technologies. And we're going to blur it so it's really indistinguishable where it is, right? Where it is doesn't matter in the cloud. So it introduced a huge number of new features and capabilities for features based on cloud computing. And this is referring to multi-latency, extensible switching, traffic shaping, built-in protection against malicious networking of behavior of VMs, bandwidth management, and a whole bunch more, which was all needed to, or for the purpose of Microsoft's Windows Server enterprise level cloud solution, all right? So keep that in mind that the server we're working with is optimized and designed to work hand in hand with the cloud, right? Now, when a comparison is made between Hyper-V and vSphere, right? A lot of times there'll be a table, and the capabilities of the CPU and the memory are they're really so large that it's incomprehensible, right? If you're Bill Gates, right? And how many of you saw the headlines yesterday is that Bill and Melinda Gates are divorcing, and there was no prenup. So Melinda's going to be like Jeff Bezos' wife. She's going to get half of his fortune. But at some point, the difference between $10 or $100 or $1,000 or even $1 million or $1 billion kind of becomes irrelevant. If I read once when Bill Gates built his custom built house in Washington, just north of Seattle, someone said that would be like a typical 9-to-5 worker, right? Like us, spending $20. If you went to, AM, PM, and you got $10 worth of gas and you got a couple Red Bulls and a Danish and, a lottery ticket, and it came out to $20. That when you spent that, you probably didn't really consider, okay, this is 20 out of my total balance available for the rest of the month is, maybe $1,000. That is, 1/50th of what I have left. I mean, we don't think in those terms for smaller amounts. Now, if it was $1,000, you'd be like, okay, do I really want to spend that here? Probably not, right? But they're so large, the numbers that these guys work with, they're so large, it's almost, like pie in the sky numbers. I mean, and that's what these numbers are. I mean, 4 terabytes of RAM, when the largest system that we'll ever get our hands on probably will max out at 128 gigs of RAM, not gigabytes, right? Billions of bytes, not trillions of bytes. So to say it's, 40 or 4,000 times larger than that, 16,000 times, right? Because 128, or yeah, even more than that, 32,000 times larger is 4 terabytes. So it's really hard to matter to, these numbers are so astronomically large that it's like, okay, that's like saying who's richer, Bezos or Gates or Warren Buffett or, the Sheikh of Saudi Arabia or whoever the richest people are in the world. It's like, it doesn't really matter. They're richer than me and you, and probably more than we'll ever make in our entire lifetime. So it's hard to look at these numbers and say, oh wow, that's I'm going to hit that number soon. We're not. Okay. But where Microsoft really has carved out an edge over VMware is with their cloud. Now, VMware does have the cloud. They have a cloud strategy. Their vCloud, right? Everything VMware has a V in front of it, vSphere, it's the vCloud. They do have a cloud, but what they don't have is the server infrastructure that Microsoft has. And when Satya Nadella, who has now been the CEO for probably close to 10 to 15 years, when he took over for Steve Ballmer, who many of you probably know him more as the owner of the Los Angeles Clippers, right? LA's B team. When he took over for Ballmer, one of the first things he said is that Microsoft will become one of the more important cloud players. He said, Microsoft, we are going to become a cloud service provider. And at the time, they were just the little guy on the block, right? They had very little experience, they had very little infrastructure. But in a short period of time, just less than 8 years since Server 2012 came out, he has moved Microsoft into the second place, as really 1A and 1B between Microsoft and the leader, which is Amazon Web Services in the cloud. So sometimes students ask me, what certificate should I get to really promote my career? And one of them that I would really recommend, and it's fairly new, is the Amazon Web Server certificates outside of the CompTIA. So you got to start somewhere, start with CompTIA and then work your way up. But Amazon Web is a great certificate to get right now. And then of course, Windows certificates are all cloud based as well. Okay, so VMware has a little catching up if they want to really compete virtually in the cloud. Okay, now another, well, it depends on, what do you mean by that, Louis? What are they based on? They're based on physical hardware. They have a data center full of servers, thousands and hundreds of thousands, probably millions of servers worldwide that they physically run on. And then as far as Linux or Windows, they're probably a Linux base that you can run the virtual machines on. I'm not 100% sure on that though. Go to Amazon.com and chat with the technician. They'll tell you. No, that'd be like finding a needle in a haystack. But that's a good question. I'm not sure what they run on. It's virtual. Something is a virtual subsystem. The bottom line is, but what the actual hardware specs are, I don't know. Okay, so another function that we can take advantage of with our virtual switches is load balancing and failover clustering, right, with the network teaming. So this is where you virtually create a network connection by combining network cards on the server. And this gives the ability to aggregate or add, right? Just kind of, okay, here's 1 gig, here's another network card with another gig. If I add those together, now my one connection is 2 gigs. So it aggregates that. And these network cards and combine them for this virtually created network connection. Now in Server 2019, you can enable this right within Server Manager. So if you go into the local server and scroll down to where we have our network cards, it will say these network cards are here, and we can click on this NIC teaming and go in and set, select what network cards we want to enable. So we just click on the disabled, then we enable it, and it will give us the options of selecting what network adapters here. And then we select them, add to new team. So we select both of those virtual, add to new team, boom, boom, done. And now our switch will have a 2 gigabyte Hyper-V team. So whatever we labeled it. Okay. Now, these have to be physical network cards that are connected, right? Now, our servers have 4 network cards in them, but only one of them is connected to anything. So we can't really take advantage of this, but in a production environment, we would make sure all those servers are connected to 4, and we probably want to even do one network card goes to one switch, another network card goes to another switch, third to a third switch, fourth to a fourth switch. So those switches are independent. So if one of the switches fails, we still have some redundancy. Okay. So then we have our network connection. Now, and that gives us the bonding or the NIC teaming capability. Now, Server 2012 also introduced the new functionality of quality of service. And QoS is where we can prioritize traffic on our network. So, it's kind of like stores like Costco, right? Costco allows at certain hours, certain people have priority access, right? Like the senior citizens have access at certain hours that regular, if you're not over 65 or whatever their age limit is, you don't have. So there's somebody there that's kind of inspecting the traffic flow, and they say, okay, this traffic is allowed, this traffic has to wait. You're not blocked. You just have to wait until that other traffic is prioritized. Okay. And that's what quality of service does. And we want to do this on our networks because not all traffic is equal, right? Some traffic, we want to make sure it never slows down, and other traffic, we're okay if it slows down. And the classic example of that is with our voice over IP or our video over IP traffic. We never really want our voice communication or our video communication to stutter or pause or buffer, right? How many of you remember when YouTube first became real popular, even before Google bought it, and you'd run a video and it was common. I mean, I remember you would start the video, you'd let it run for maybe 10 seconds, you'd pause it, so it'd give it time to buffer and catch everything up, and then you would play it. And hopefully by the time you got to the end of the video, it wouldn't have to buffer again. Otherwise it'd stop and say buffering, buffering, buffering. Well, on our networks, we want to prevent that. So we can go in and we can say that we are going to manage our bandwidth. Okay, so this is the settings that we come into our network card, and all we do so far is we just select what virtual switch. So we hit this drop down and we say LAN A, LAN B. That's what we've done so far, but we could also go in and enable the bandwidth. And we can prioritize our bandwidth based on the quality service. So if this machine, this VMH-W8001, If this machine is only doing, say, file sharing and say DHCP, so it's just a typical member server, we may say this is going to, the maximum we're going to give it is 25 megabits out of our 1 gigabit, right? So that's what, 200 megabytes, or this 25 megabytes, so that'd be 200 megabits out of our 1000. So we're saying the maximum you get, so our pipe is 1 gig, you're only going to get 1/5 of it. We're just going to, that's your straw. You don't get the whole pipe. You're just going to get a little, pixie straw that to drink out of. And that might be okay based on the functions of this server. Now, if this was our telephone server, if we had a virtual LAN network for our voice over IP system, then we would probably say you get, up to the maximum for the 100 gigabits or 1 gigabyte per second. All right. So this is where you can go in and set that. Now for us, we're going to leave them all equal. We're not going to use this because for us, we just want to get them to work first, and then we would come back and fine tune this later. All right. So quality of service is a set of technologies that allow you or provide you with the ability to cost effectively manage your network traffic and to enhance user experiences in our enterprise environments, small offices, and even our home environments. For example, you can prioritize with quality of service traffic for latency sensitive applications, such as voice or video, and to control the impact of latency insensitive traffic, such as bulk data transfers. So this is where we can say, this, I want to make sure this doesn't slow down, and this, I don't care if it slows down. Okay, so that's what quality of service is. And the way we can do that is we can, with the bandwidth management, the classification and tagging, then priority-based flow control, and then policies that are based to enforce our quality of service. All right. So bandwidth management is used with that section of the network card, and we can do it from there. Now, the fastest wired connection right now is 10 gigs. We could team 10 gigs to get bigger than 10 gigs. That we could easily do that, but the way we assign the bandwidth is with the weighting. So we can say certain things like storage. Our storage network would probably want to have a high priority. Live migration and cluster sharing, we could share that, and we could assign a weight and say, okay, 50% will go for the storage, 30% for live migration, and 20% for the cluster sharing. And that would break up our 100% of available. So if everything was going at the same time, storage is our priority, and then clustering would be the lowest priority. And the reason we put clustering lower than, say, even live migration is the only time that clustering will need bandwidth is when it fails over. And hopefully our infrastructure is solid where we're not going to have a lot of fails. So we could probably live with, okay, we'll give it 20% of the total, and that, we can live with that. Okay, but the storage, we want to make sure that storage is always running at the highest priority. Okay, so certain things that we can use, we can tag certain built-in functions, such as iSCSI, which is one of the transports for our network storage. NFS is another protocol used with our storage. SMB, which is the protocol that is used with our file shares. Then live migration, SMB direct, and then a wildcard that we can say to anything else. And there's certain ports. iSCSI uses TCP or UDP port 3260. NFS is 2049. SMB is 445. Live migration uses port 6600. SMB direct, we'd have to specify it when we set it up and then specify it when we do it in the quality of service. And wildcard is anything else. Okay. So we could go in and set this up to do this. Now you can use policy-based quality of service to manage network traffic on the physical network. And this enables you to specify network bandwidth control based on the application. So not the protocol or not what the traffic looks like, but what application it comes from, the user, and even their computer. So we could say, okay, we're going to give, say, a network game. Let's say some people are playing, Call of Duty or, Fortnite or whatever on our network. And we know about that. We're not going to, prevent it 100%, but we're going to say, okay, you can play it, but it's going to be so slow. You're probably not going to want to play it at work, right? And that's the way IT sometimes, handles the problem. Have any of you ever seen the movie Office Space? Came out in the 90s, and Milton is working there, even though they thought they had gotten rid of him years ago, and he's still on the payroll and he still shows up every day. And the Bobs say, well, we'll just stop his payment. We'll just go to HR and say, okay, don't pay Milton anymore. So they're going to fix the glitch, right? So sometimes, instead of just going and telling them, hey, you don't work here anymore. You haven't worked here for years. I don't know why we've been paying you, but, and be real upfront with it. In IT, we can do kind of the same thing and say, well, I don't want to be the bad guy to say you can't play any games on our network, but I'm going to make it so painfully slow that you won't want to, right? You can do it if you want to. We're not going to prevent it, but we're going to make it, really crappy so you're not going to like it. We could do that based on that. But what if you set that policy that says, okay, any traffic going to, Microsoft's Xbox servers, we're going to give it the lowest priority, 5%, right? They'll get just a trickle. Well, what if the owner of the company comes to you and says, hey, my grandson comes in, on Wednesdays and he spends the afternoon with me and he has his own computer, but he's saying he can't play this game. Can you make an exception? That's when the politics of, position, right? Owner, IT manager, we're quite a few steps apart. You're probably going to do that, but we won't do it for everybody. But we could say, if this computer connects, it has a special policy, so we can make exceptions and go get around it that way. All right. So that allows you to do that. Now, policy-based quality of service provides the ability to enforce the minimum bandwidth, configure and query the policies which enforce minimum maximum. We can use group policy. So just like we went into our group policy to change our password policy that it meets the complexity requirements, right? So that we can use our password, or we use it to enable the LAN workstation so we can actually use the file share. We could go into group policy, and there's a section where we can enable quality of service policy, and we can configure the local QoS policies on computers not joined to the domain. So even if they're not a member of the domain, which once they're attached to the domain, whatever organizational unit they're in, we can set a specific group policy on that, or we can just have it the default group policy. It will enforce that. But what if they're not attached to the domain? If they're just plugging into our network, never attaching to our servers, to our Active Directory, well, there's a policy that we can still enforce that through the computers that are not joined to the domain, right? So let's stop right here. This is a good spot to kind of stop. So those are some of the benefits, or the why we would want to use some of these virtual switches on our networks, in our virtual environments. And as you can probably imagine, the functionality of these switches is very, very similar. In fact, in a lot of places, it's identical to a actual hardware-based switch. So a physical switch that will allow us to take advantage of the same things. So, I mean, if we were going all virtual, if we told our boss, yeah, let's move everything into the virtual environment, and then all of a sudden, the things we could do with our physical switches, we can no longer do. And your boss says, well, why aren't we doing this anymore? Well, we can't do that in our virtual environment. They'd probably want to say, well, let's get rid of the virtual environment. Let's go back to the better, where we could do everything. Well, now with Hyper-V, we can do that in the virtual environment. So that's a selling point, right? That's an optimization of the virtual, right? A simple orange monster, right? The optimization part of it and the management part of it, where we can really take advantage of some of these technologies. All right, so let me put me in the center here so you can see me. So let's take a short break here. Actually, we'll take about 9 minutes. Let's come back right at 9 o'clock, and then we'll continue going here, right? So I'm going to pause the video here, or the video that I'm capturing, and then we'll start back up at 9 o'clock. All right, welcome back. So let's start up again. And as we've mentioned, there are 3 types of virtual switches we can create: the external, the internal, and the private. So let's describe each one of these as we go. So here's the virtual switch manager. And if you select this create new virtual network switch, it'll give you the option external, internal, or private. So like what we did last week, we said we want an internal, switch that is, and then we hit create, and then we give it a name. So here is where we can create our external. Now, the only thing about an external switch is it has to have a one-to-one link to an external network card. So we would need to have more than one external network card. We would need another cable and an active network connection to do that, which we don't have. So we can only have one external switch on our virtual machines, okay? So, but the external switch allows the system, so it gets bound. The external switches are created to build a bridge between Hyper-V and the external network. So if we need to bridge our network connections, so if we want our virtual machine to be on the same network that the host machine is on, we have to use an external connection. Now, the first external switch is created during the install of Hyper-V. So when it installs Hyper-V, it asks you, do you want to use this connection as a switch? And if you just use the default settings, it will automatically do that for you. Okay. Now, the external switches, you can create as many external switches as you want in Hyper-V, but they must have a physical adapter connected to it. Okay. Now, the nice thing about Hyper-V building the first one, remember, we can have up to 256 connections on one of these virtual switches. So we could put all of our VMs on that external switch, and it could handle it. Whether or not it'd be a good quality of service and network management would be another story. All right. So there's the external. And the next one is the internal. And the internal switch allows communication to happen only between the virtual machine and the hypervisor host, or other virtual machines connected to the same internal switch. So it basically just says whatever's connected to this internal switch can communicate. And when you build the internal switch or create it, it automatically connects your virtual switch, the internal switch to the host machine. So if you were to look on your host machine and look at the network cards, you would see that last week when we created LAN A and LAN B internal switches, it has now a connection on your host machine, a virtual adapter that's created in your host machine's network card properties. And one of them say, well, LAN A, the other one will say LAN B. So it builds a virtual internal connection. So the host machine and the VMs are connected. Now, the difference between a private switch and an internal switch is that the private switch does not build a connection or have any interaction with the host machine. So if we wanted to isolate a system and not have it have any outside communication, only in our virtual environment, then we would use the private switch. Okay, so the private switch only connects to the virtual machines that are connected to it. All right. So that's a quick review, since we've already done this in a couple of our networks, of the networking. So now I'm gonna talk about PowerShell. So one of this gets into kind of well, in the olden days, the old timers, you know, kind of one of those conversations. So one of the most important skills that server administrators should possess is the ability to automate tasks, right? If you were tasked with creating new users every semester, put them in the group that they belong to, assign their permissions for their file share, set their quotas, delete all their temporary log files, and all this. If you did that manually every single semester, and say you worked at Mount SAC where there's tens of thousands of new students every term, you'd be spending all your time working on one user, clean, next user, and it'd be an insurmountable amount of work, right? You would probably say, this IT stuff isn't for me. You know, I'm just not, it's too much, right? One of the hallmarks of mankind, right, human history, is that we have developed ways of doing things better, right? We're not, you know, fishing, commercial fishermen don't use a single line to catch, you know, all the fish they need to take to the cannery and, you know, do all the stuff that they do, right? They have nets and traps and, you know, technologies that allow them to do that. So the ability to use tools is what separates man from the rest of the animal kingdom. So old timers that worked on Unix, a lot of times we have this image in our head that they were just these old lazy hippies that would create scripts, and they would just press, you know, run one command, and it would do everything, and then they wouldn't have to do anything for another 6 months, right? And that was because the scripting power of the command line in Linux and Unix has always been there, but it hasn't always been in Windows until PowerShell. Now, I say that scripting doesn't make you lazy, it makes you work smarter. So, you know, you've probably heard the old adage, you can fix anything with a big enough hammer. Well, that may be true. You can probably fix what you need to fix with the hammer, but there's better tools sometimes, right? Tightening a screw, yeah, you might be able to pound it into a position where it will never come loose again, but a screwdriver might actually be a little more appropriate for the job, right? So scripting is what this is all about with PowerShell. Now, PowerShell is a shell first. And when we say shell, we're referring to the user interface. So how do you interact with the operating system? And the two basic models are the command line interface, where everything's done from the command line or from PowerShell or from the terminal in Linux, or a graphical user interface, which for us has been very helpful in learning this stuff, like say in Server Manager. So in Server Manager, by now, we've done this enough times in this course. If you see a task, a punch list that says install DHCP, your hands will probably automatically go to, install feature or program, service or program, and click next, select DHCP, click next, next, and wait for it to install, then go into the DHCP tool to manage it, right? That's just kind of the way we learn things, is graphically first, but PowerShell comes after the fact. Now, PowerShell is first a shell, so it gives us access to the operating system. And then second, it's a scripting language. So we can take advantage of automating these tasks using scripts. Okay. Now, early versions of Microsoft's operating system could only use the graphical user interface. And this was in stark contrast to Linux and Unix capability. So, if you went for a job interview and your experience was only in Windows and they were using Unix, they would really look down on you. They'd say, well, you probably don't have the skills that we need, because we're not just point and click. I mean, you can't click your way out of solving this problem. You have to actually run the commands from the terminal. So this was a weakness that was perceived compared to an administrator that did know the command line interface. Now, the scripting language, so there's a language behind the PowerShell. So even though we type the commands, there's an interpreter that will turn those into actual code that the computer can understand. And it's based originally on the POSIX shell grammar, and then it includes some evolved versions of all of the major computer languages, with Perl, Python, Visual Basic Script, and C#. And it's kind of uses a little bit of everybody, which makes it very, very universal. So if you come from a Python background, so if you've done a lot of web development and you use a lot of Python code, you're going to very easily adapt to PowerShell. Or the same thing if you come from the granddaddy of all programming languages, C, and whether it's C, C++, C#, and work with PowerShell, you're going to be very comfortable with the syntax or the way the code's written, because it has evolved from C as well. Okay, so there's a lot of elements that it borrowed from. Now, PowerShell was available in Server 2003 and Windows XP, but it really wasn't until Server 2008, which was based on Vista, or I shouldn't say based on Vista, but it had the same graphical user interface as Vista, as Server 2008 did. It wasn't until that was really launched that Microsoft started moving it into a lot of usage. Now, all Microsoft products have utilized a heavy integration with PowerShell, and this is especially true with Microsoft's mail system known as Microsoft Exchange. So Microsoft Exchange has some functions that can only be done from PowerShell. So there are certain features that you need to turn on or off. There is no graphical user interface. There is no checkbox that says on or off. The only way to get to it is within PowerShell. So, and that's a trend that Microsoft is moving in that direction. So some of the ability to not only install, but also manage these Microsoft products is going to require that we know Microsoft PowerShell. All right. Now, you can obtain PowerShell from the Download Center, and it's already installed on our modern systems. So Windows 8, Windows 10, Server 2012 and newer, all come with PowerShell 3.0 installed and ready to go, right? So to get to it, all we have to do is right-click on our start and select PowerShell, right? And with the creator update for Windows 10, which came out a little over a year ago, it automatically changes what's in the quick launch or the right-click. Used to say command prompt. Now they switch it to PowerShell. So they're moving everybody to PowerShell. All right. Now, it's an installable feature in Windows Server, and Windows PowerShell uses the Microsoft programming framework, which is known as .NET. And the .NET framework allows, it does all the interpretation of the commands. And because .NET includes a whole bunch of programming languages, right? If you've ever installed like Visual Studio, which is the programming application, the interface, the programming development language for or environment for programming on a Windows machine, is the Visual Studio. It uses .NET as the background. So it's the framework on which all the programming is built. And it's built into our systems, right? Windows actually runs on top of, it's created with .NET, so it's very, very connected to it. Now, we can run a single command in PowerShell to perform a single task. And we're going to do some of this in just a little bit. Or you can combine multiple commands into a PS1 script to perform multiple tasks. All right. So we can add these into a text file, give it the name of .ps1, and then just run that .ps1 file, and it will go through and run all those tasks in the order that they're listed. Okay. So let's watch a couple of videos here. And this is where I have to stop my share, and I'm going to switch to my sharing my screen. Let me share my screen here, and then I'm going to open that PowerPoint. Then my links are going to work. Let me get down to where we were. And it's on my other monitor, so I need to share my other monitor. There we go. All right. So can you still see the PowerPoint there? The only thing is I'm not picture in picture here. But let's click on this link here for a couple of really short videos on PowerShell.
What is PowerShell? Hi, I'm Don Jones, and you probably, unless you've been living under a rock, heard about Windows PowerShell, and you probably think you know what it is. Maybe you think it's a scripting language, or maybe you think it's a command line shell, but It's really kind of none of those things and all of those things. And if you're going to take advantage of PowerShell, it's important to understand what it really is. This is Windows PowerShell. Interestingly, this is also Windows PowerShell, and it might surprise you to learn that this is also Windows PowerShell, sort of. You see, Windows PowerShell is an execution engine. It's kind of a background thing, and it runs commands that accomplish tasks, such as creating new Active Directory users or installing roles on a server. You, as a human being, can't actually interact directly with that PowerShell engine. You need some sort of interface. This graphical user interface, Server Manager, is one such interface. When I click links and go through wizards and click buttons in here, really behind the scenes, I'm just generating Windows PowerShell commands. There's some other tools like that. The Active Directory Administrative Center is one of them. So I can come in here and I can open up a user's properties, and this is a grand graphical user interface, and it's all nice and pretty, but look at the bottom, Windows PowerShell history. These are the commands that get run to accomplish whatever tasks I'm performing. So if I want to create a new user, for example, and I click OK, a PowerShell command actually ran under the hood to do that. New AD user, set AD account control, set AD user. Now, one of the ways that you'll probably spend a lot of time interacting with Windows PowerShell is this console. This is where you get to manually type out the commands that you want it to run. It's important to understand that Windows PowerShell is not a scripting language. It is a shell, much like the Unix shells out there, Bash, C shell, and so forth. Like those shells, Windows PowerShell does contain a scripting language, but at the basic level, you can just run commands. Get process gets me a list of processes. And what's neat is that these commands can be connected to one another in something called a pipeline. So I'm going to take the output of get process, I'm going to pipe it to another command called sort object and ask it to sort those on the paged memory property. And then I'm going to change my mind and have it sort them in descending order. And then I'm going to decide that maybe that's too much. So I'm going to pipe that output to another command and have it just select the first 10. And there we go, the 10 processes that are using the most paged memory on my system. I didn't have to write a complicated script to do that. It was just a command. At some point, I might want to decide, yeah, this command I kind of run fairly frequently. So I'm going to copy that to the clipboard. I'll run the integrated scripting environment, paste that in, and save it. And we'll call it get top 10 processes.ps1. So now it's a script. Now, instead of typing that out manually, I just run get top, and I'll hit tab to complete the name of that. I can repeat that. Now, did I write a script? Yeah, sort of. I tend to think of these more as a batch file, but whatever you want to do. You can even get fancier with them. For example, maybe I want to do this against a different computer sometimes, so I'll define a parameter that can accept a computer name. And on get process, rather than getting the local processes, I'll get the ones from whatever parameter that was. I can save that. I'll go back to the console and demonstrate it. Now I can add my script computer name parameter, give it the name of a computer, and it'll retrieve the top 10 processes from that computer, assuming I have permission and that all the right services and everything else are running. So it's really kind of easy to go from using this as a command line shell to a batch language or a scripting language. And the neat thing about PowerShell is you don't have to learn all of its capabilities up front. You can start small just by running a command or two. And as you need to do more things, you can learn how to do those things. And you'll gradually build that skill set over time, rather than having to kind of choke it all down all at once. There's a lot of built-in discovery mechanisms like the help command that helped me find get process in the first place. There it is right there, get process. The help for individual commands that helped me learn how to use this thing, including all of the built-in examples and all sorts of great stuff. So you don't even have to spend a lot of time on Google or Bing looking up syntax. A lot of it is right here for you. So Windows PowerShell is a shell. It's designed to accomplish things. You can interact with it through this console interface, through its integrated scripting environment, and sometimes through the graphical user interfaces that you're already familiar with as they run PowerShell commands in the background. The good ones will actually show you what commands they're running so that you can use that as another PowerShell learning experience. No matter how you choose to use PowerShell, it is powerful, and it's worth your time to get used to it and start using it for all sorts of different tasks in your environment. I hope this has been informative for you, and I'd like to thank you for viewing.
All right, so that's one of the videos. Let's check out this other one.
So there's probably three reasons to learn PowerShell. First of all, yes, if you just want to create a user account or stop a service or something, doing it from the GUI is way faster than figuring out the PowerShell command. Once you've figured out the PowerShell command, though, a lot of times we as IT pros have to do the same thing over and over and over again, configure 27 web servers or something like that, and you want consistency. The great thing about PowerShell is you can cut and paste text. So you can do it over and over and over again. That's the first value. The second value is that once you've expended that time once, okay, it was 3 hours to figure out the first time, but it's 5 seconds afterwards. The second thing, though, along those lines, is the boss is constantly saying, did you document what you did? Or did you just document it? You know what? If everything you do in PowerShell, you copy and paste it to Notepad, here's a documentation, boss. It's documentation that runs itself. What it means is you can rebuild the system in almost no time at all. And by the way, 2A is, you know, they do these salary surveys on a regular basis about what IT pros make in the Windows world versus the Unix guys. Unix guys make like $10,000 a year more than we do. And you know why? It's because they're not clicking. They're working in the black screen, you know, the screen and the command line stuff. And they don't have that C:\\, users mark greater than sign. Oh, no. They got a prompt like %sign or $sign, which is odd because you'd think if there was an operating system that had a $sign as a prompt, it'd be Windows, you know? And so, you know, the boss goes by and they're typing awk and trough and grep and ls, and the boss is like, I couldn't do that stuff. You got to pay these guys some more money. With PowerShell, you can look really, really cryptic, so that could be more money. The third reason is there are times that you have to say, you know, it happens maybe 5 times a year, maybe twice a year. You've got a complicated problem. Find everybody who meets this criterion and delete them or unlock them or whatever. And you know, in the BB script days, that was 3 days, a lot of prayer and a lot of sweat. In the PowerShell world, we write a one-liner where we're taking one command. That's where we find the victims and we feed them into the slaughter trough or whatever it is, the filter and the hammer. And once you've done a few of those, when I'm trying to do this, what I do is I used to try to teach PowerShell. That was a big mistake. What I do now is I try to teach how to administer your AD using PowerShell. And by the way, you end up learning PowerShell in the process. And it's the simplest thing in the world to learn to glue them together. And by the way, that was 3. 3A is, and this is important, Microsoft has this thing they do where once they decide to PowerShellize something, Exchange was first, and then one of the system centers and virtual machine manager, Active Directory, this thing happens where once they get the PowerShell religion, about 15% or 20% of what you want to do, you can only do with PowerShell. If you want to turn on the Active Directory recycle bin, which is an awesome feature, PowerShell command that's longer than me. And you have to learn that much PowerShell. The Active Directory recycle bin appears. Wonderful stuff. Undelete users only works with PowerShell. I'm not an Exchange guy, but you know, teleport an Exchange guy into this chair and he or she could give you 15 great Exchange things you can only do with PowerShell. So to a certain extent, I'm going to give you reason 3B is resistance is futile. We will assimilate your technology. If you want to be an AD, if you want to be an administrator, you have to at least learn PowerShell to do that kind of stuff. Oh, and in the end analysis, once you are comfy with it, and it's so easy. That's the thing. Okay, this is 4. I told you 3. No one expects the Spanish Inquisition. So the fourth reason is PowerShell is an administration tool where watch that first step, it's a Lulu. But when I do it, I'm teaching people, is we spend forever on get-AD user, which is the first PowerShell command. Once you're past that, we are blasting through the rest of the commands. Because like, oh, remember the dash confirm? Yeah, it works here too. And remember the dash what if works here too. And oh, by the way, remember the dash, and this is how we find the positional parameter. All that stuff just falls into place. You spend an hour on your first PowerShell command and 15 seconds on all the others.
So that's a couple of videos there for the PowerShell. Very, very interesting stuff. Excellent, excellent videos. All right. So finding PowerShell or launching PowerShell. So what we can do is on your machine, if you just type power, you'll get PowerShell will pop up, right? So here I've launched PowerShell on my home computer, right? And you know it's PowerShell because it says Windows PowerShell at the top and then PS. And because I'm in my namespace, or I'm logged on as Ken, so it puts me in my profile of C users Ken. Now, if I were to run PowerShell admin, I'll get the UAC, and then on Windows 10, it puts you in the C Windows System 32. It also tells you at the top, administrator PowerShell. So some commands you have to be an administrator to run them, all right? So let me come back here. So launching it is pretty easy, all right? So if you have a Windows machine on your home computer or a virtual that you can access at home, you can go ahead and launch this, right? So here's the command line interface for Windows PowerShell. So again, it tells you an administrator and away we go. Now, PowerShell does adhere to the Windows security constraints. So a user of Windows PowerShell can't do anything that they don't have permission to do. So just because they open PowerShell doesn't make them an administrator, right? It's still going to follow their ACLs, their access control lists, and their permissions that are assigned based on their authentication, authorization, and accounting. Therefore, a non-elevated user may not have rights to perform such tasks as installing a printer driver, reading the security logs, or changing the system time. So you may get errors indicating a permission problem. So to avoid this, because we are administrators on our own systems, you should launch PowerShell as an administrator. So for example, if I open PowerShell as a regular user and type get-disk, this will come back with, well, on mine, because I am a local administrator, but if you're not, you'll get an error. And this tells you what hard drives are in my computer, right? I have a C drive, I have a, or the serial number here, the computer name is there. So you can see that sometimes you'll get an error that access to SIM resource was not available to the client, and it will go from there. But then if you run it as an admin, it will work out and you'll see everything, right? Now, Windows PowerShell commandlets all work in a similar fashion. So it's just like the guy in the second video said, once you kind of work your way through a couple of the examples and get an idea of how it's set up, the remaining part of it is it all kind of falls into place. So all commandlets have two parts. They have, the first part is the verb. Now, we know from our English courses that a verb is an action, right? It's an action word. It does something. Although in PowerShell, it may not be strictly defined that way from grammar. Okay, so the first part is the verb, and then the second part is the noun. So And we know a noun is a person, place, or thing. So we want to do something to something, right? Or get something from something, or we want to add something to something. So the noun is what we're working with. The verb is what are we going to do? So it goes verb dash noun. So the verb indicates the action for the command to take. And some of the more common examples are get, set, add, remove, format. And then the noun is the thing to which the verb applies or the action applies. So for example, we can say get process, set service, get disk, remove network adapter. Okay. So the ability to kind of think of what am I trying to do and what am I trying to do it to will give you the verb and the noun relationship. Now, the dash combines the verb with the noun to complete the PowerShell command. Now, these are named commandlets because they behave like small programs or programs that are used standalone or pieced together through a mechanism called the pipeline. So I'm going to come back to that term pipeline in just a second. Now, the most common verb is get. So in PowerShell, so let me bring this back up. This is my administrator. If you want to know what are all the get verbs, what can I get? If you just type get and then hit tab, it will scroll through all of them. If you just hit get dash, it will give you, there's a way to get all of the gets, but you can use tab completion to go through and scroll through all of these systems here. Okay, so what do you want to get? Well, you can just look at it that way. All right. So the ability to use PowerShell really comes into tab completion. The ability to just type part of it and then hit the tab key, and it will scroll through in alphabetical order the options. So, and this will really help you with two things. One, you're not going to have typos, right? How many of you have used Linux and you type out this big long command, hit enter, and you get an error and you're not sure where the error is, and then you have to go through and proofread what you just typed, and a lot of times there'll be a typo in there. The same thing will happen in PowerShell, because do you really want to type get-net adapter encapsulated packet task offload ? No, I don't want to type that. You don't want to type that. So what you do is just type get-net, hit tab, and then if there's no response, type a little bit more, hit tab until you get the response that you're looking for. And it's going to be nice and neat. And then the other thing, in the video that guy said, 2A is it leaves a footprint so you can document everything you're doing. So if you wanted to write a manual or a procedure manual for, say, a new hire on how do you do this how do we add all the users at the beginning of the term, you could use PowerShell and then just save all those commands, copy and paste them, and write little notes in there, and it would be perfect. I mean, they would say, okay, this is how I import the users. This is how I add them to the domain. This is how I set their default password. This is how I add them to a group. And they would be able to go through and do that in, minutes instead of hours. So it saves time, the tab completion. So when you're doing these today's lab, make sure you take advantage of tab completion. Okay. Now, commandlets are the functional drivers of PowerShell. So we can use commandlets to invoke any runtime operation, or we can combine multiple commandlets together to complete a series of steps to take full advantage of automation. Now we can run these commands against our local machine or on a remote machine. So if we have permissions and we set up PowerShell on the other machine to allow remote execution of commands, we can reach out and touch everything in our domain from the comforts of our office chair, and all we have to do is open PowerShell, and then we can connect and do everything on everything. Okay. So the beauty of PowerShell is that you can very easily combine these commandlets to work with each other for carrying out the intended operation. So for example, in the first part of the PowerShell command, we can call a command like get-star, which will show us all of the get commands. So if I do get-star, it will, well, the star we have to fill in here. So the get-star is not recognized. So yeah, so that's still not there. There's a way to list all these, and I'll come back to that. All right. So for selecting all the objects for the same attribute, and then in the second part of the command, we can use another command to set it. So like we can find what we want to work with, and then we can change it with the second part. So to combine those together, we use what's known as the pipeline. Okay. So here's where we can do the get command, and that will show us all of the commands that we can use get with. So this will give us a long list that will go through there, and then we can sort these lists with other tools as well. Okay. So how are normal Windows command prompts? You're probably thinking, what's different between PowerShell and the command prompt? Well, PowerShell uses the .NET framework, okay, which is that programming language, that programming capability to interpret the command and then run code against it, whereas the command prompt only runs if there's a standalone binary executable for it. Okay. So for example, if we type the ping command, if I type ping, and then, you know, Robert, you said you spent hours pinging for the firewalls. Ping 192.168.1.99, the command prompt says, run the ping.exe command with this IP address. Okay. Whereas if we do PowerShell, get dash, network connection status, it will use the .NET framework. There is not if we search through all of our executables in our System32, we're not going to find a get dash network adapter information.exe. It's built into the .NET framework. So this gives us the ability to run these commandlets without having to have compiled the source code or the executable on our system. Okay, so it's very much more flexible. So command prompt commands are usually less compatible with the piping mode, and whereas commandlets in PowerShell are. So a single commandlet can be piped with another command, and this combination can perform a complex task as easily as possible. So if I wanted to ping a computer, and then the ones that have a response, if I want to go in and enable their firewall, I can't do that with a command prompt, but I can do that if there's a command for that in PowerShell. Okay, so the ability to combine these functions together is what makes PowerShell powerful. All right. So pipeline is extremely easy. So here I run the command get-service. So I want to see all the services that are running on my machine. And then this FL gives me the full listing. So it'll give me an explanation of all of it. If I just do get service, I get just a cryptic list here, get desk service, and boom, it tells me all the services that are either running or stopped. But if I pipe it to the full listing, now it will give me a detailed look at all of them. And if I want to say, give me that, but I only want one page at a time, it will give me the first page, and I can hit the space bar and I can scroll down. So let's say I'm looking for my browser service, and I want to see which ones are running and which ones are stopped. I could sort this by the various things here. And then to get out of this, you just hit Control C. All right. So the ability to pipe this is very, very powerful. Now, PowerShell implements pipelining similar to the way Linux does, with a couple of differences. The main difference is that in Linux or Unix, the pipe structure or can use unstructured data, which means it can work with the output from the first command, and even if it's not text or if it's code or whatever, it can, the Linux command can do, pipeline can handle that. Whereas PowerShell, it has to use one of the data types, right? Which is either a character, a string, a single variable, a complex variable. So it has to fit one of the .NET framework things. Now, what is really kind of neat is PowerShell has created aliases for some of our common Linux commands. So if you have a user that is really good in Linux, but they're not super familiar with Windows, they can come over to their use PowerShell, and all these commands that they've used in Linux, like ls, the list command, will work. LL, unfortunately, doesn't have that. So not all your Linux commands are going to work exactly the same way, because they're only aliases. Now we can create aliases, so we can make PowerShell function almost identical to the way it does in our Linux environment, if you wanted to do that. All right. Now, if a Linux Unix shell, everything is text-based. So output from one command can be piped to another, but the receiving program must know how to parse or interpret text from the pipeline. Now, this is the main difference between PowerShell and Linux, in that in PowerShell, everything that gets passed through the pipe is considered an object. So the receiving program doesn't need to know how to interpret it, because that's what the .NET framework is there for. So it gives us the ability to take the output from one command, send it to another command, and that other command doesn't even need to know how to deal with it, because .NETwork will do it for us. So it gives us a huge amount of flexibility. Okay. Any questions so far? Anybody have any comments or questions here? Let me get the chat. Okay. Not now. So far, it makes sense. All good. Okay. None here. Good. So let's say that we wanted to create a new hard drive. So I'm gonna do this on my machine. Let me see if this will work. So if the first thing I need, if I'm gonna work with Hyper-V, import module Hyper-V. Let me see. Now I don't know my machine. I don't remember if I have Hyper-V installed. So it doesn't, I don't have Hyper-V installed. So what I need to do is I'm gonna, we'll take a break here and I'm gonna connect to my server on campus, because some of these commands are specific to Hyper-V. Now, if you don't have Hyper-V on your home computer, these aren't gonna work. The lab, everything we do in the lab, you can do on your home computer in PowerShell. Okay, so as I mentioned in at the beginning of the lecture, today's lab is all about PowerShell, and you can do it on your home machine, you can do it on your server that you remote into, or you can do it in the virtual machines on your server that we've created so far. If you're on your home computer, it's probably going to be the easiest to work right from your home computer. All right, so it's 9:51. Let's take another break here, and we'll come back to PowerShell right at 10 o'clock. And then around 11, we'll switch gears a little after 11, and we'll jump into today's lab. All right, so let's pause right here, and then we'll, all right, so what I'm going to do, let me get to the internet and go to Guacamole. Password. Okay with Authy. No, thanks. All right, so. All right, so I'm gonna log into my server. And I'm gonna launch PowerShell. All right, and hopefully, let me share my screen, that might help too. All right, so with PowerShell here, if I do import guest module, and then Hyper-V, that because Hyper-V is installed on this machine, I can import the module that allows PowerShell to work with Hyper-V. So if I want to create a new hard drive, I can do new -bhd and then tell it where to put this hard drive. So I'm just going to say, I'll put in my ISOs folder, and I'm going to name it SQL.bhdx. So let's say I wanted to create a new hard drive, and then I can do size in bytes of 15 gigabytes. So if I hit enter here, it created that drive. So here I'm just going to say dir ISO. So I'm just going to show you what's in that ISOs folder, and you can see it created this SQL.bhdx. And it's 4 gigs right now because it's an empty hard drive. Okay, so if I go to the next slide here, so slide 56, and I do the information, it shows me that it creates everything without any problems. So what if I wanted to create a new VM? I can do new dash VM and then give it the name of, and whatever I type here in the quotes. And I can tell it how much memory startup bytes, and I want to give it, say, 4 gigs of RAM, and I want to use the hard drive that I just created. And so I want to use that SQL hard drive I just created. So this will create a new virtual machine right there. So now if I open Hyper-V Manager, you can see that it created a new SQL test VM. And if I go into the settings and look at the hard disk, it's actually using the C ISO SQL.vhdx hard drive that I created. Okay, so the power of PowerShell will allow us to see all of that stuff very, very easily. So let's get caught up here. And you can see it will create this new SQL VM. Now, we can also create a new virtual network switch. So here's where first I need to know the name of my internal network adapter, or my physical adapter, so I can use the get net adapter, and I find the name is Ethernet. And then I can say, create a new switch with an called external with the net adapter name of Ethernet. And then that will go out and create this new adapter. So in this machine, I had 2 network cards, and it's going to create the second one with the external name. It's an external switch. Its name is external, and it's going to use this Intel adapter for it. Now we can't do that on our host machine because we only have one enabled external adapter, and it's already bound to our external switch. But I can get the list of all my VMs. So let's say I want to see all my VMs here. So I'm going to say clear. And if I just do get VM, it shows me all of the VMs that are on my machine. So if I wanted to close these or stop them, I can get them and then stop them all on the same command. So let's take a look at that. So I'm going to do this, get it, and then I'm going to pipe it to stop them. And there's a lot of stop commands. So stop -VM. And notice when I type this, if I hit tab, if I spell everything right, it just puts it in the case that it's used to. Now, case sensitivity doesn't matter on PowerShell. Okay, it does on the Linux command line. So that's another distinction. So here I'm going to get all my VMs and then stop them. And I get these warnings that, hey, none of these are running. So I could start and stop those remotely. All right. Now you can also do some text output here. So if I wanted to do a random number, so here I'll clear this again. And if I just do 1.5, it's just going to type the numbers 1 through 5. But there's a get dash random, and I'm going to do the input object, and I'm going to say it's going to be between 1 and 10, and I want to get the first 5 random numbers. So this will give me 5 random numbers. And it just gives me between 1 and 10, it gives me 5 or 8, 6, 5, 7, 4. So if you wanted to use this to say, what's the largest number in Powerball? 65, something like that. And you want to get your 5 numbers. So here's my 5 Powerball numbers, and then I just want to get my Powerball number. I could use that and go buy a ticket, and those are probably the winning numbers. I mean, without a doubt, those will probably be the ones that will win tonight or whenever the next Powerball drawing is. So you can use PowerShell to do some little fun stuff too. Now we can also do some sorting. So we can sort, we can do get service, then sort by the service name. And we're going to first sort by the status. So we want the running to be first, and then the display name, we'll do it in descending order. So these services are only the ones that are running. And it's in the name in descending order. So the starting at Z and then working our way back down. Right? We can also do a whole bunch of other stuff, and you're going to do a whole bunch of other stuff in today's lab. So PowerShell is there's a lot to PowerShell. And if you're on Udemy, there are some really great classes. Just wait for them to go on sale when they're like $5 a class instead of, you know, 85 bucks. And take a couple of those if you're really interested in it. There's a really good blog, this guy, Hey Scripting Guy, where he has his top 10 favorite PowerShell tricks. So you can do some scripting here. So he talks about the transcript, and the transcript, you run the transcript, and then it saves in a text file all the commands that you're working on. Okay. You can look for hidden objects. You can use the expand property. So there's all kinds of options when it comes to PowerShell. Okay. So any questions briefly on PowerShell? And today's lab is strictly PowerShell. So all you're going to do is go into PowerShell, and I wrote up some examples, and then I have you do it, and then I want you to copy and paste that, put it back into the document, and then submit that to the lab 10 submit lab there. Okay, and all that's unlocked, so you can, and again, you can do that on your home computer, or you can remote into the server, and it will work no matter where you're at. Okay, if you're on your home computer though, you have to have Windows 8 or above. All right, so the next thing we're going to briefly look at is storage. Since we introduced, you know, we created some new VMs, and then we created some new differencing disks. Let's kind of talk about what we did last week. Okay, now when it's a VM is created, it simulates an actual physical machine, which means it needs a hard drive, right? It needs some sort of storage. So virtual machine storage requirements are based on the type of the server that it's running, and different servers have different best practices for where things should be. So like a database server or a SQL server, you want the operating system on one volume, you want the system swap file on another, the application on another, and then where are the database files and the database logs located? SQL recommends those are on separate volumes. So this virtual machine, if we were to create a SQL server, we would want to create, different hard drives for the different aspects. Now, remember, we talked about in week 9 that the ability to understand what are we doing up front helps us plan better, right? So this would be an example of that. Now, the table previously shows what's recommended for SQL. So if we use the wrong type of disk, it can adversely affect the performance of our SQL server. So we want to, know that beforehand. Now, earlier versions of Hyper-V had some problems with storage. One, it didn't have the ability to perform live storage migration. That wasn't a feature, right? They added that there. It also didn't work well with fiber channel storage. So that was a problem. And it had a limit on the hard drive size to 2 terabytes. Didn't work well with iSCSI, and the disk merge operation on a VM was incompatible with different. If a VM was running, you couldn't merge it, so you had to actually turn it off, merge it, turn it back on, and then it would complete the merge, which was time intensive. And remember, one of the benefits to using a virtual environment is we can improve our downtime, right? We don't want a bunch of downtime on our virtual environment. So that was a problem. All right. Now, since Server 2012 and above, it allows us to use fiber channel, large drives, live storage, and it has the native support for the 4 kilobyte sectors, and the live disk merging all happens automatically. So they've addressed those problems and fixed it. Now, the 2 file types, which we have when we go through that, is if you're only working with hard drives that are smaller than 2 terabytes, VHD will work just fine. If you're going to use VHDX, those can grow up to 64 terabytes in size. All right. So many small to medium-sized companies struggle to have this needed storage area network, right? We addressed this earlier when we talked about storage with VMware. And the one thing that we can do with Hyper-V that we can't do with VMware is we can actually use our file shares in Windows. So if we have a server with a file share, we can actually use that for where our VMs can be stored. So we might not be able to afford a big SAN, but we may be able to build some NAS, right, with our network attached storage, and then we can use Hyper-V to mount that and use that available storage. Okay. Now, this will enable you to store virtual machines based on Hyper-V on the cheaper disks of the file server. Now, cheap is relative because you're going to save money on the cost of the disks, but you're going to pay a price with the performance. So, yes, we can do it, but it's going to not be optimal as far as storage performance. Right now, here are the 4 disk types that are supported in Hyper-V: the dynamic disk, the fixed disk, the differencing disk, and a pass-through disk. So let's define those here. Now, dynamic disks are the default. So when you create a new VM, it will automatically default to the dynamic disk. And a dynamic disk, you basically say it can grow up to its maximum size. So when we say it's going to be 40 gigabytes, that means it can go up to 40 gigabytes in disk size. So it's going to start at 4 gigs, right? That's the default size. And then it will just keep growing as it gets bigger and bigger. Now, If you create a 40 gig, it will only take up the space required. And if you install server 2012 or 2019 with the dynamic disk, it takes about 8 gigs of actual space, which means it can grow up to 40 gigs. Now, dynamic disks, since they're not fixed in size, they don't deliver good input-output performance, but they're fast and they're easy to build. So, we'll trade that off for performance. We'll sacrifice low performance for ease of use. Okay. Now, if we select here the fixed disk, that's going to assign and use 40 gigabytes right from the beginning. Now, fixed disks are always recommended for production workloads because their better performance allows administrators perform faster read-write operations on virtual disks, whereas a dynamic disk has to expand as needed and then write the data. So it's like a 2 or 3 step process for a dynamic disk in a VM, whereas if we say it's 40 gigs from the beginning, it can read and write that a lot faster. So performance is better with a fixed disk. Now, the fixed disks are usually used on VMs that run disk-intensive applications where high input-output is required. A file server VM should use a fixed disk. On this same server, you could use a dynamic disk for the operating system because it's not going to change frequently. Whereas a file server, people are going to add and subtract, move and copy and delete files, add files to their file server. That disk is going to be a kind of a accordion size. Fixed disk would be best there, but the operating system, a dynamic disk is probably okay. Because once you install it, it doesn't do a ton of adds and changes, right? Now, a differencing disk, which we used last week, has a parent-child model associated with its architecture. And when we use the checkpoint, which is the snapshot feature in Hyper-V, it does the same thing as a differencing disk. So if we have, that's why I recommend we don't use snapshots in this class, because we're using differencing disks. So we're taking a snapshot of a snapshot, which can cause problems. And the parent and the child have to use the same disk format of either VHD or VHDX. So I can't create a differencing disk that uses VHDX if I'm going to use the parent disk, which is VHD, or vice versa. It will not work. Okay. Now, differencing disks are the same in nature as dynamic disks in that they grow in size over time. So differencing disks, like dynamic disks, are not recommended for production workloads. So you probably already picked up a couple of things that we're doing wrong according to best practices in our labs. One, we're using dynamic disks, which in a production network, we would use fixed disks. And two, we're using differencing disks that also have the same capability of dynamic disks, which are not recommended in a production environment. Okay, but for our learning environment, they save us a lot of time. Okay, so and then the last type of disk is a pass-through disk, and this is a disk which is attached to the local server, the Hyper-V host server, and then it's not used by the host server, but it is passed to the VM so that they can use it as a raw disk. So in this type of storage, the physical disk passes through the hypervisor, and then later is used by the virtual machine. And pass-through disks are not included in the volume shadow copy service. So if we're going to use backups, the native backup or a third-party application backup, it will not see, the VM will not see the pass-through disk in the volume shadow service. So that means if if you have taken a backup of a virtual machine using a volume shadow service-based backup, all the pass-through disk of the virtual machine are not backed up, and only the VHDX based disks will be included in the backup. Pass-through disks give us the best performance, but they're not included in the backup. So we have to make sure that we remember that and we back them up. Okay, so some of the best practices: dynamic disks are not good candidates for high input output, and it's strongly recommended that all critical virtual machines, especially ones that mostly get access by end users, are created with fixed disks. And differencing disks can lead to data loss, which means that they can build a chain in which many differencing disks are interlinked. That's why I had you set your parent disk to read only, so that nothing can change on the parent. It's only going to change in that VM that's the child. So if anything gets corrupted, it's not going to affect the parent, which would infect all the children. So there's that. And then pass-through disks are recommended for databases. Now, SANs typically have built-in fault tolerance, which is essential for our databases as well. All right. So here's an example of a storage area network where we have our two nodes in our failover clustering, and then our SAN, and then our client. So we're going to do a lab later where we'll build a similar example to that. All right. So that's all the lecture material I have for today. But I want to take a quick look at today's lab. So if you go into week 11 and go to lab 10 and then open this. And this is a good lab to kind of work at your own pace. There's not a lot of tricky parts to this one, but let's just look at this. So download this file and then take your screenshots and pop it in there. But the goal for today's lab is to get you familiar and comfortable with PowerShell, which has been around for a little over 10 years now. Now, I have some details on when it was released. And then if you need to connect, I still have that in there. I put that on every one of these. So what we're going to do today is really kind of bounce around PowerShell and then run a PowerShell game too. So I'll show you how to do that here. So any Windows machine is going to have PowerShell. It has a lot of information about the command structure, which I want you to read, and then to launch PowerShell. And once you're in PowerShell, it has the blue background with the PowerShell. Now, one of the things that that we saw with the video is there's also this ISE, which is the oh, why won't that? I want to get this over here. Which is the integrated shell environment. So the commands that we type here, like get dash, see how it fills it in a little bit easier for us? And then if we run it, so we can run them here, and then we can copy this information. So if I want this command, I can just copy it and drag it right up here. So if I wanted to build a script, you know, get process, and then I want to sort descending, and then I want to count the first 10, and that's okay. Well, there's some ways we can get around all that. So the integrated environment is there, and you can see that. We're not going to use that today. I mean, you can if you want to further expand this. So let's start by defining some of the basics here. So the first thing I want you to do is look at the get command with the verb get. So you probably saw about 100 commands with the verb get go whizzing down. So what you're going to do is just go through this in order and just do what I did here, and then pay attention to what's in there, because I'm asking you, what's the difference between the get command dash verb get and then measure object, and the get command dash verb dot get in parentheses with the dot count? And are the results the same? So just tell me yes or no. And then how would you do a similar command for instead of get command? What if you did this for service? So you just do service dash command dash verb service, and away you go. And then paste a screenshot of your PowerShell command that you used for this. And then paste a screenshot that shows how many total commands, not for the verb of get, but all commands. So you're going to have to modify that a little bit. So just work your way through this lab, and I introduce a topic, and then I have you work with it to find some of the information. Okay. And if you pay attention to the lab, it's going to make perfect sense to you. So you'll be able to, I say paste a screenshot. Now, some of this, you're going to have to read the output. You may have to go into the help. You may have to actually look at what's going on. If you just type and go, it's not going to be correct. So pay attention to what is actually happening in the lab. And then the last thing I have you do, so we work with some objects and we do some variables, first name, last name, and so forth. And then the last thing I have is on today's lab, there's a some code here. Let me show you that you can download and then copy and paste that into PowerShell. So this game1.ps1. So just download this, and you'll see this is a file. And if I open this in folder, and then I'm just going to copy this to my desktop. Okay, and then that's the PS1 folder or game. So if I go to my desktop and I look, I have my game.ps1. So if I go dash game, okay, and then run this, this is going to ask me, do I want to run it? And I do want to run this. So I'm going to say R.
Ahoy matey. I'm the dreaded pirate Robbins, and I have a secret. It's a number between 1 and 100. I'll give you 7 tries to guess it. What's your guess?
So it's between 1 and 100. Let's do 44.
Too low, ye scurry dog.
So
what's your guess? Too high, ye landlubber.
So I know
What's
it's
your guess?
44 and 66,
Too
55.
high, ye landlubber. What's your guess?
So let's try it.
Too high, ye landlubber. What's your guess? Too low, ye scurry dog.
So I only
What's
have a
your
couple
guess?
guesses left.
Too low, ye scurry dog.
So now I know it's either
What's your
48 or
guess?
49.
A vest. Ye guessed my secret number. Ye did.
So that's just a fun little game I found, and then I modified it for us that we can that you can run in PowerShell. So when you're all done with that, submit the lab and you'll be on your way. Okay. So any questions on what you'll be doing today? I'll be on Zoom if you have any questions, but you really, this is kind of a self-paced lab. You should be able to kind of bounce your way through it. And again, you can use your home Windows machine if you have one. All of this will work identical, or you can log into your server with Guacamole and then do it on there. All right. Any questions or comments?
We just do it with the host machine, right?
Yeah, you can use your host machine, or you can
Okay.
use a virtual machine, or if you have a Windows machine at home, you can use that. Anywhere you want to do it, it'll all work the same.
Okay, so we can do it on anything.
Yeah, it has to be a Windows machine though.
Okay.
All
Thank
right.
you.
Any other questions?
To submit for the lab, it says it's locked till May 17th.
Oh, okay. Let me fix that. Are you already done with the lab?
No, I was just talking, because I usually just stay on that tab and it just says it's locked.
Okay. Yeah, let me change that date.
Yeah, I haven't started the lab yet.
Oh, thanks. Thanks for catching that though, because sometimes when these things get imported, the dates don't work out right. So you have until Sunday at midnight to submit this lab, by the way. And I'm going to do that on every week. So if you work on the lab during the lab time, and then you want to, double check something or rework it or come back to it, you really have all week to do that. All right, so now it should be available to you to submit. Let me make sure.
Yeah, it is.
Okay, good. Oh, wrong one. All right, any other questions on anything? So I'm basically releasing you to work on this, and then I'll be on Zoom until around 2 o'clock, because I have a meeting. I'm on the outcomes committee and I have a meeting at 2 o'clock. But if you have questions after that, just send me an email. And the reason I can't be on Zoom for this and that is you can only be in one Zoom meeting at a time, unless I Zoom one on my tablet and one on my computer. Then I need 2 user accounts and it gets complicated. All right. So if there are no questions, I'm gonna kind of just be monitoring Zoom. I'll leave my microphone, my speakers on, so I'll be able to hear you. And just if you have a question, just pop it in the chat and I'll help you. All right. You guys good? Okay, good.